talk about some vector operation. Okay, so let's start with vector addition. Okay, let's start with vector addition. So in vector addition, let's take two vectors. Okay, let's say x is equals to 4 7 12. Okay, 4 7 12, and let's say y is equals to 13 9 4 10. Okay, now we know x plus y will be equals to, I'll teach you how to do this. So here you have to add the individual values. The addition is like adding matrices. Okay, adding matrices. So we know we have 4 here, here 9. So it will be 13. And then we have 7 here, 4 here. So it will be 11. Here we have 12, here we have 10. So it will be 22. Okay. So this is the addition part. All right. I know this computation is really easy, okay, but what I'm trying to tell you is we need to know what happens behind this. Yeah, we have to know what happens behind this. So let's try to make sense of this. But as I told you, it's easy to first talk in 2D before we go into 3D. Okay, so I'll just take the I value and the J value. Okay, the I value and the J value. So we have the I axis, and then we have the J axis. Okay, so in the I axis, first of all, let's represent what x is. Okay, let's represent what x is. So we know x was equals to 4 7 12, but here we are talking about I value and the J value. So instead of putting 12, I'll just stop with 4 and 7, and let's just have y, and that will be equals to 9 and 4. Okay, so now we can draw this. So we have 4 here and a 9 somewhere here. And we know 4 is somewhere here and 7 is somewhere here. Yeah, 7 is somewhere here. Okay, so the x's, okay, x is somewhere, it looks somewhere like this. Okay, it looks like this. X looks like this. Okay, and then we have y, which is 9 4. Okay, so it should look something like this. Okay, you can see that. Now what happens is we are going to add two of these vectors. Okay, we are going to add these vectors. You can do it this way. Okay, you can do it this way. So what happens is, since you are adding, you will add to the point where the first vector ends. Okay, you will add to the point where the first vector ends. So now you can see here. All right, now you can see here, we know this is 9 units, and we know this is 4 units. Okay, this one is 4 units and this one is 9 units. Okay, so we know this one is already 4 units. Illaya, we already know that is 4 units. So the resultant will have the resultant vector. Let's say the resultant vector is z. Okay, the resultant vector will have the x value or the I value as 13, because we can add 4 units and 9 units, and we will be left with 13 units. Similarly, here we know the j value of x vector is 7 units. So if you add those two, you'll get 7 units plus 4 units, which will be equals to 11. Okay, so this is what actually happens. So if you want to represent z, z will look like this. Okay, z will look like this. Okay, so I'll just mark the arrows. So this is x and this is y, and here we have z. So this is what happens when we are adding two vectors. Okay, and you can see here this looks like a triangle. This looks like a triangle. Let's write the z first. So z is 13. Okay, 13, and then we have 11. Okay, so you can see this looks like a triangle. And this triangular addition of vectors is very important when we are learning about position vectors. Okay, so first let's focus on the vector operations. Okay, so we know addition now. So I'll give you another example so you can try that. Let's say we have 4 over 3 and 2 over 7 and 1 over 9. Okay, and you have to add that with minus 3 over 4 and minus 3 over 4, 5 over 7 and then minus 1 over 3. Okay, now we know we have to add these things. Yeah? So here we have 4 over 3, here we have minus 3 over 4. So 4 over 3 added with minus 3 over 4 will give us 12, and we will have 16 here, we have 9, so 7. So it will be 7 over 12. And this one simple, 207 plus 507 is 1, no worries. And 109 minus 1 over 3 will give us minus 2 over 9. Okay, so this is what addition of vectors look like. This is what addition of vectors look like. So from this, you will be also able to understand how to subtract vectors, the subtraction process, okay, the subtraction of the operation. So what happens is, let's say x is equals to 9, 12, 13, 9, 12, 3, and let's say y is equals to 4, 2, minus 4, 4, 2, minus 4, okay, and if you subtract y from x, it will be equals to 5, 10, and 7. How did I come up with that? Well, 9 minus 4 will be equals to 5, 12 minus 2 will be equals to 10, and 3 minus minus 4. 3 minus minus 4. So we can actually multiply these two and the product will be addition. So 3 plus 4. Okay. So shall we check this? Shall we check this? Okay. What happens here? Okay. And let's try to understand visually. Okay. Let's try to understand visually. So here we have, let's talk about the the I axis and the J axis. Okay. Let's talk about the I axis and the J axis because it's easy to visualize in two dimensions. Yeah. So we know x will be equals to 9, 12, and y will be equals to 4, 2. Okay, I'm going to take, instead of 4, 2, I'm going to take minus, okay, minus 4 and 2. You'll see why. You'll see why. So, since this has minus 4, I think we have to go this side also. So, I'll draw that too. Okay. So, now, first of all, let's draw x. So, x is somewhere here. 9 is somewhere here, right? Let's say 9 is somewhere here. And 12 is somewhere here. Let's say that. And this will be x. So, I can draw that. No worries. So, it's somewhere here. Yeah, somewhere here. So, this is x. And let's see what is y. Okay, let's see what is y. So y is minus 4 comma 2. So it's somewhere here. Minus 4 should be somewhere here. And 2, obviously it's, if this is 12, you can say this is 2. Yeah. And we can draw that. Okay, let's keep it green and this will be white. This will be white. And yeah. Now we have to subtract y from x. Okay, subtract y from x. I can think of that like, okay, I am adding a negative version of y. How can I think about, how can I think? I can make the thought process such that I am adding a negative version, okay, a negative version of y. Okay, so we know if some vector looks like this and let's say that is z, well, the negative of that will be in the opposite direction because the negative sign, the minus sign, represents the direction. So we can say like that. Okay, similarly we are going to do here. Similarly we are going to do something here. Okay, so look at what I'm doing. So I'm going to draw the opposite. Okay, I'm going to draw the opposite. So let's first of all copy this. Okay, first of all let's copy this. Yeah, it's not working. So well, I'll copy this. Control C, Control V, and this should go in the opposite direction. So I'll draw here. Okay, and I have to draw the arrow in the opposite direction. I have to draw the arrow in the opposite direction. Why? I'm adding a minus y to this. Okay, so if this is y, this will be minus y. You can see that, right? You can see that. So here, if this is minus 4, the minus value of my y will be 4. And if this is 2, the minus value will be minus 2. Now we normally do the addition. Okay, what are we going to do? The addition. Well, see here. Okay, Control C, Control V. I'll add to the point where this ends. That's it. Simple as that. And this is minus y. Okay. And now we know this one. This one here, okay, is 9 units. The I value or the I coordinate value of x is 9 units. Vector x is 9 units. And here the x value, the I value, okay, the I value of the vector y is 4 units. So the output will be, the resultant will be 13 units. Similarly, for x, the vector x, the j value is 12 units. It has 12 units. Okay, it has 12 units. But y is, the negative y is going downwards, in the downwards direction. So it is in minus 2. So the output will be 10 units. The resultant vector will be 10 units. So I can connect these 2 points to find the answer. Okay, I can connect these 2 points to find the answer. And that will be equals to z. We can say that is equals to z. And we can say z is equals to, okay, 13, 10. See, it's in 13 and it also connects to 10. This is what happens when you are subtracting vectors. Actually, here also you are adding the vectors, but you're finding the negative vector of the one that you're going to subtract. Okay, so keep that in mind. Alright, now let's talk about multiplication. Okay, multiplication of vector. But first of all, let's learn about scalar multiplication. If you multiply with a scalar value, what happens? Okay, so let's say we have a vector x, and let's say that is equals to, who knows, 1, 2, 3. That's easy. Yeah, let's keep it simple. 1, 2, 3. And what do you think is the value of 4x? Well, we know 4x is equals to x plus x plus x plus x. So that is 4x. That is 4x. So you can simply multiply 4 into 1, 2, 3. So it will be equals to 4, 8, 12. This is what actually happens. So even if you are multiplying, what happens is you are adding the vectors. You are adding the vectors. Okay. What about 1 over 6x? Well, 1 over 6x is, we have a complete x. Okay. We have a complete x. Let's say this is x. Okay. It's 1, 2, 3. So it should look like this. Yeah. So it should look like this. It should look like, so it should look something like this. I'm not talking about the k plane, but let's just say this is x. Okay, so this is the x. If I enlarge this, okay, if I enlarge this, it should look like this. Okay, I'm just enlarging it. Okay, let's say I'm just enlarging. Okay, I'm just enlarging it. So this is x. So here is this x. Okay, this x has 6 parts. Okay, we can divide it into 6 parts. Okay, we can divide it into 6 parts, and one of that part should be 1 of 6, 1 over 6 x, 1/6 of x. Okay, 1/6 of x. So you can say it is 1 over 6, 2 over 6, and 3 over 6, which will be equals to 1 over 6 over 1 over 3 over half. That's it. Okay, what about minus 3x? What if we have minus 3x? Well, that is equals to 3 into minus 6. And we know minus x is the opposite of x. So minus x is equals to minus 1, minus 2, minus 3. So but 3 into minus x will be minus 3, minus 6, minus 10. That's it. So if you understand the addition of vectors properly, if you can visualize the addition of vectors properly, well, that will be useful to understand other operations that you can perform with vectors. Other operations that you can perform with vectors. So this is the main focus here. Okay. So this is the main focus here. And we'll talk about position vectors in the next video.
Thanks for watching the second video in our vector series. If you found this breakdown of vector addition, subtraction and scalar multiplication helpful, don't forget to like, share and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.